Welcome to the Digital Amateur Television Experimenters Night. This is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. You can also participate in the night by coming up to the Queen's Domain club rooms. Yes, right on top of the Queen's Domain and the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind, doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30pm local time. We'll see you soon. This is VK7 OTC.
Okay, this is VK7 OTC, the club station, the Radio and Electronics Association of Southern Tasmania, and you've got Justin at the mic, VK7 Tangled Whiskers. And just to kick off, I wish to acknowledge Tasmanian Aboriginal people as the traditional owners of the land upon which we're presenting tonight, and pay my respects to elders past, present and emerging, for they hold the memories, the knowledge and culture and hopes of Aboriginal Tasmania. So we have a huge night tonight, and a whole lot of very diverse subjects. So I hope I can do them justice, and I think we might be able to get through them in the time. But we'll see how we go. So the very first segment I was going to do was give you a little bit of and I've termed it Behind the Veil. And Behind the Veil means an inside look of how we have created our digital GPS locked beacons, which is what's in this little box here, which I'll go into in a sec. But so just acknowledging, we've got hello to Andy in the UK, Colin in VK, we've got Matt, we've got Darren. We've got Paul, hello Paul, and Stephen, VK3 TTF. So hello Stephen from we've just recently joined the ATV Discord channel and started putting some content up there. So hello Stephen from our ATV guru in VK3, I think. We've got Ron and Andy saying hello to everyone there. So fantastic. I'll try and keep an eye on the chat. So if you've got any questions, please put them in the chat, and I will attempt to answer them. So we're doing some modifications to our digital beacons that used to be down at a place called Snug, which is down in southern Tasmania, on a wonderful property hosted by VK7 TPE Peter, and we're about to move them, and so there is some work being done on our beacons. So what that gives us the ability to do is the beacons are on my test bench at home right at the moment. So I thought, okay, we can show you the inside view of these beacons and actually show you how we generate GPS locked frequencies and how we generate the digital the WSJT modes in the digital beacons, as well as obviously CW and a few other modes. The beacons, as they currently stand, we're licensed for 6 meters, 2 meters and 70 centimeters, and we've just added a 23 centimeter frequency to our beacon list. So the way that we generate these, and I'll show you now. I just bear with me because studio front. Here we go. I'm going to try and do. Oh, look at that! Trying to do a bit of a zoom in here. Let's go up a bit, and then if we zoom in at that, and we get it to focus, it'll focus in a sec. Oh, there we go. So what you're looking at here is, for those who have probably already recognised these, there is they are Wayne Knowles, who unfortunately, ZL2BLK, who was unfortunately silent key. He very suddenly died a year or so ago, and so the ZL-PLLs, which are these three boards here, you can see they're labelled 70 centimeters, 2 meters, and 6 meters. These ZL-PLLs are digital frequency synthesizers up to, these are the 4 gig modules, so up to 4 gigs. You can get also, there is a version of these that goes to 14 gigs. That quite a lot of the 10 gig experimenters have ZL-PLLs in a variety of their 10 gig gear. But so the way that this actually generates the signal, the frequency, and also the obviously the modulation that's actually on that frequency, is these frequency synthesizers are driven by the repeater controller, which is also a Wayne board. This has got a little microcontroller on it, and also it has its own little GPS unit on here as well. That goes off through this ribbon cable to each of these units, and it directly drives the digital synthesis to provide the modulation type on each of these frequencies, and you can then set these frequencies through the configuration. There is a wonderful surprise, a little USB that goes off this board, and you can configure this to do all sorts of things. Currently, each of these go through a cycle, a 1 minute cycle of CW on-off keying, so straight on-off keying. Then it goes through a CW frequency shift keying mode, and what it's putting out is obviously the call sign, which is VK7RST, but it is also it puts out the grid square, it puts out the temperature, it puts out a few other things that this particular board is picking up. And so you can receive those through CW, and you can also receive a shortened version of that. Obviously, it goes into a JT4B and then a JT65 cycle, and that's on 6 meters. On 2 meters, it goes through the same thing, but it's JT4B and then it goes to JT65B, slightly different mode. And then on 70 centimeters, it is CW on-off keying, frequency shift keying, and then it just has a JT4D mode that it outputs on, and that'll be the same configuration for the 23 centimeters. So now, how do we GPS lock everything? This particular board here, which is a tiny little postage stamp board, and I mean postage stamp, it's about the size of a postage stamp. I actually put it onto a breakout board that brings it up to 0.1 form factor output. There's a little PCB, transition PCB that's in there. This is a full GPS module. You put one of the hockey puck antennas, the little dongle antennas. I think there's 5 volt goes up this line, and it sits on the roof with the little hockey puck. That provides 10 meg locked at GPS, and there are a whole lot of if we have a look at the front, you can see these are the status LEDs for the GPS module. So this is warming up, this is locked on, there's an alarm, and if it's doing a satellite survey, then this particular light comes on. So if you change the position of this, the survey light comes on for a little while it does it updates its almanac. GPS in here, you'll notice it gets divided off both to this module and also to the repeater controller. This has a little U-Blocks GPS module on it as well, so it has a separate GPS module. The one from this postage stamp goes to this little distribution board here. This distributes the 10 meg. One side's the input, and then there are 3 outputs, and there's a 4th one here which I'll use for the 23 centimeter, and that then gets distributed to these SMAs on each of these DDS boards, and then there's an SMA that comes out the back. Now this is a repurposed 2RU box. It was actually, I think from memory, a Sony video switching box. So these were all I think BNCs that were poking out the back here. And it all runs off of 12 volts. These SMAs, so this comes out at absolutely flea power, but what these are driving are 3 KL 150. So there's a 6 meter version, a 2 meter version, and a 70 centimeter. It's the PAs in the KL units, if you know KL repeater units, and they are putting out about 20 watts each, and they're driven by, there are 3 switch mode computer HP computer switch mode power supplies that sit there supplying the current for those 3 PAs. They are running at about 10 volts. One of the nice things with KL PAs is you can run them at lower voltage, and of course there is the lower current as well, and lower power that's dissipated as well. So that's one of the really nice things with KL units. So those switch mode power supplies, the voltage is just turned down on them. There is I think it's a 3-line 16 character display on this, which gives you the status of what the beacon controller is doing, what each of those frequencies are transmitting. It also gives you obviously the GPS time, GPS date, the grid square. It gets the grid square from the GPS and calculates that itself, so you don't have to do any of that sort of stuff. There is, you probably noticed in here, there's a coil up here there is a temperature probe. There's a thermocouple on the end of that, which gives you the temperature inside this box. Now this box sits it sits below all of the PAs, and I specifically did that so that all of the, for those who don't know, KL PAs, KL 150 repeater boxes, the whole side of the box is a heatsink. That's one of the beauties of KLs and why they're so bulletproof. The whole side of the whole top, literally, of the KL unit is a heatsink, and so the power's being dissipated, and obviously heat rises. So you don't want to put this in the top of the box, or this will probably cook and have trouble staying on frequency. So I put this in the bottom of the box, below the power supply unit, and then there are 3 PA units on top of that. So and I'll just point out here, this is the Alan Ruthven VK7ZAR, who he was called the Tsar. That was his nickname. Silent Key Memorial Beacons. So Alan used to got the original beacons together, the original 6 meter beacons together that used to be up at Mount Nelson. So we named it after him. Now let's see if this will do it. Oh, there you go. Now have I forgotten anything? Just let me consult my notes. Oh, and we've got some more comments. We've got Nick, VK3NIK. Hello, Nick. Ventilation, yes. You're spot on. There are plenty of holes in the back, and they're not big enough to let mice in. Hi. So yeah, there you go. No, I think I've covered most of that. Now, the last thing is the antennas. So, what antennas do we run on this? Fortunately, the location that these beacons are in is the top of a hill, and so on top of a machinery shed, there is a pole. On the very top is our 70 centimeter halo antenna. So it's a fully aluminium halo antenna, and then just below that there is a 2 meter folded dipole for the 2 meter section, which is horizontal, and then there is a 6 meter dipole, just a straight dipole, that is obviously horizontal, and all of those are slightly out of they're not all lined up, they're slightly misaligned on purpose, so that they minimise the amount of interference that they cause to each of the antennas. And there isn't any at this stage any filtering on any of that. It's a radio quiet zone from our perspective. There are very few other services that we need to contend with up there. So there your card. A test card at the beginning is also available in 16 by 9. Okay, thanks, Miles. Great. Now, the next segment I was going to show you, and this is also with a few pictures. A couple of weeks ago, there was a whole bunch of us, and I mean there was about 20 amateur radio and other people who were also all got together to do safety communications for the Tom Quilty Equine Endurance event. So those who don't know, an Equine Endurance event is a horse rider on a horse goes around a course which is laid out, which can be 20, 40, 80 or 160 kilometres. Now 160 kilometres, the reason it's 160 kilometres is that's 100 miles, and for Andy in the UK, they do 100 miles on the back of a horse. Now they don't do it all in one go. They lay the course out so that there is like a 40 kilometre loop, and then there is another 40 kilometre loop, and then there is sort of a 20 kilometre loop, and there's might be a 10 or a 5 or whatever else, and they put together the combination so that they end up with 160 kilometres, which they have to do within 24 hours. So they start at midnight on a horse. So they've got, all of them have got headlamps on. They start at midnight. They go through each of the loops and back into base. And in base they had, I think they had, it was 6 or 8 vets. And what the vets were doing welfare checks on the horses. And so the 160 kilometre endurance ride is all about looking after your horse and not pushing it to the point where it's going to be vetted out. And the vet checks temperature and checks that it's not lame and checks that everything's okay with the horse, and then gives the tick of approval for it to go out on the next leg. And so you've got to do that. Each time it comes in, it gets vet checked, and you can get to the very end and you've done your 24 hours of 160 kilometres and be vetted out. So you can imagine what it feels like to be vetted out right at the end after riding on a horse for 24 hours. Now, our role in this is we provide safety communications, and what that means is at various checkpoints around each of the courses, there are a bunch of us who are there, and we need obviously more than a couple because it is 24 hours that we have to be potentially on a checkpoint. And so what we're doing is we have a radio. And I'll go into the radio in a sec. We have a radio. We're obviously, it's in the middle of the night, so you need things like lights and all sorts of things, and I'll go into that as well. And on our particular checkpoint, we were on one that had a RFID reader. So each of the horse riders have around their neck a lanyard, and they've got a card, an RFID card, which is connected to their. They've also got a bib on that's got a number on it, which is very handy because they call out their number as they go through the checkpoint. And we write that down and make sure it goes through the reader. So we've got an iPad that is wirelessly connected to the reader, and as they go through, the reader beeps, and you see their name and their number and a time and a date stamp that gets put on that. That gets sent back to base via a 70 centimetre link, and base have a database that they look after and they're monitoring. And that's on some big show screens outside of the base caravan, so that riders can look and see how people are going on the course. So most of the time the horses go through. There's usually watering points at a checkpoint, so they have a drink. They might have something to eat. We give them. We've got lollies. We've got water. We've got supplies and bits and pieces that we can give riders. And they go through, and most of the time it's absolutely uneventful, which is great. But every so often, and we had the situation where a rider rocks up, obviously a rider, had a bib on, the whole bit, but absolutely no horse. And the rider had come off the horse further up the track. It fortunately was not injured. But that rider was looking for her horse, and because it was a black horse with a black saddle in the middle of the night, they had not a hope in hell of finding this horse. And so we radioed in to say that rider number X, Y, and Z had come off the horse, was okay, was looking for the horse, etc. So we had a fire going, so they were at least able to get warm and all sorts of stuff, because it's the middle of the night and it's bloody freezing, to not put too fine a point on it. We were able to then radio that in. If there was somebody go through a checkpoint and they lose their RFID tags, which they do, then we can radio that through and say rider number XYZ went through the checkpoint and we give them a time. And so they manually put that into the database. And 9 times out of 10 we had another rider come in and they had another RFID tag which they hand in. And so if we then know who that rider is, we can then give that back to them when they come through the checkpoint, if they're coming through the checkpoint again. So and the other scenario is that they had was a rider throws a shoe, horseshoe, throws a shoe. They need a farrier, and so we can they come into the checkpoint. And we can radio through to say it's checkpoint XYZ, we've got rider number and we're needing a farrier. And so a farrier then comes out, reshoes the horse, and they continue on. So there's all sorts of scenarios. And the worst case scenario is obviously where you have an emergency, somebody's come off, they're injured, and you need to then get base to organise ambulances and all sorts of stuff, which unfortunately happened at Hamilton earlier in the year, and the rider was really seriously hurt. So yeah, there are a whole range of scenarios, but it's all about the radio side of it. So I thought I'd give you, from a radio perspective, so we're all amateurs, or most of us are amateurs, and Matt just asked, did they find the horse? Yes, they did. It was towards dawn that they found the horse. The horse had basically wandered off into the bush. They did find the horse. The rider got back onto the horse at that point in the course, and they were allowed to continue. But she continued and realised that the horse was really spooked, and she actually she withdrew from the competition altogether. which was a bit unfortunate because she was wearing bib number 1, which meant she was the last Tom Quilty winner that was obviously looking to defend her title and all sorts of things, but unfortunately the horse had a different idea. So, but they did find that they found the horse. The horse ended up being floated out. You ask for a float, you tell them a location, and a float and a four-wheel drive magically appears. So yeah, that's. But I thought we're amateurs, and I'll give you an idea of the radio setup that I run on equine endurance events, and using the Tom Quilty as an example. So what I've got here is a number of photos, and just let me find my cursor. It's here somewhere. I'm still getting used to the new arrangement. Where's the cursor? Oh, there it is. If I come back over here, or maybe oh, come on. Where is it? Apologies about this. I got to find my find the cursor. Oh, there it is. Okay, got it now. The screen that's sitting next to me is a 4K screen, and effectively the screen area is off each end, so the cursor can be all over the place. So let's start with the antenna. What we've got is, so let's come in here. I have a Pajero four-wheel drive that has a rooftop tent on it, and you can see here the rooftop tent's down, but the roof racks here, I can take the end out of the roof rack, just unscrew a screw, take the end out of the roof rack, and I've got a little aluminium angle iron. That's why would you say that? Aluminium angle. That I've got some bolts in there, and they slip in, and I do them up, and it provides me with a antenna mount here. Now I've got up to an 8.1 meter mast in 3 sections that I put together. Now I haven't actually got a picture of that, but it's about a 42 mil in diameter aluminium mast. It bolts together the 3 sections and gives me about 8.1 meters if I need it, or 5.4 meters. It goes through this U-bolt, and then in the on the ground I've got thanks to Richard VK7ZBX, I've got a steel cup, which is a pipe, and it's got a couple of holes in the plate that I can then put some pegs in, so the bottom of the mast is not going to go anywhere. And I hang on. No, wrong way. Now, so that then comes back to, and in fact, actually, let me just go to here. So that's the antenna. I have a X50 white stick dual band, so it's 270 centimeters, white stick collinear. That goes on the top. I've got there's a clamp arrangement that it slides into, and 2 bolts, so that goes on the top of the pole. The coax, which is cell foil, so low loss 50 ohm cell foil. It's got 50 N-type crimp connectors on either end, and I've got a 50 meter length and I've got a 100 meter length. That gets taped onto the pole, comes down, and it comes down to, I've got a FT 7800 antenna transceiver, so 270 centimeter transceiver that has a really nice feature of you can take the head off, and so what I do is I grab that out of the car. I've got an extension cable, which is a straight through RJ12, and I've also got a figure of 8 for the speaker. Unfortunately, the speaker doesn't come down. There isn't a speaker in the head. So you've got two cables. And all I've done here, and this is, Ron won't be impressed, but all I've got is a metal bracket that I made up, which fits the head and also fits a speaker and a suitable length of cable. In fact, there's mud all over this speaker cable, and that sits on a table. And I can show you how what it looks like. We've got, oh, here we go. This is the middle of the night. This is the middle of the night. You can see I've got the awning out. We've got a camp table set up, and we're checking a whole lot of figures and trying to work out why who's gone through and who hasn't gone through at this particular point in time. But you can see they're all working under the awning, and this just the radio arrangement just sits on the table. So that's the arrangement. You can see. Oh, here's the really spooky picture. In the middle of the night when it's quite cold, horses sweat a lot, and what you end up seeing with their headlamps when they come down the track, they sweat, and so there is this absolute fog around all of them, because it's the horse sweat actually. And the light highlighting the cloud that surrounds them. This is the RFID. This is the RFID point. You can see there is a RFID antenna here. It's on a tripod. They go past that. They don't need to be very close to it, and it goes bing. And we know. And we've got a that's also a little Wi-Fi hotspot. And we've got an iPad that we use to see who went through, whether they registered, etc., etc. So anyway, this is a few of the horses at the watering point. Here's me giving out lollies to riders, and also water and all sorts of stuff. You can see I'm pretty well rugged up there in the really cold polar, the really cold down jacket, the puffy jacket, because it was cold. But that's pretty typical as they go through. Here's the arrangement. If we zoom in here, we might be able to. Yeah, there's the radio sitting there on the desk. Now, what do we do for light? I'll just point this out. Peter Otten, who was with us, bought this wonderful Ryobi. This is a Ryobi standard like cordless drill battery, and this is a light that you can put in all sorts of orientations. You can dim it. You can only have one panel. You can have both panels. You can do all sorts of things. And all Peter had was a couple of pre-charged cordless batteries, and fantastic little lighting arrangement for the desk. So there you go. Now, so this was the checkpoint during the day, and you can see we're all set up. The rooftop tent's up there, and there you can see there's the mast, and it goes up to a white stick on the top, which is not very. Oh, there we go. There's the ground plane just here. Just there, and it disappears into the trees. But anyway, now I normally run a if we zoom in here, I normally run that's the 2 70 centimeter antenna that is just let me go up a bit here so that I get everything without the reflection. Let me just, there we go. I normally run an SG 7500, which is a diamond antenna on the bull bar, and it just happened to be where I parked was a bit dodgy. Probably would have had some issues during the night, so we decided to put up the mast. We had the mast. You can see this is our campsite just before we were about to leave. We had fire set up. Now this is let me go this way so we get a bit of a bigger. You can see it's at Sassafras. This is huge. There would have been bordering on 1,000 people in 2 paddocks. There was 140 odd horses. Each of those had a rider and at least one strapper, and usually their families that all came along. So huge undertaking. Here's the trophy. This is the Tom Quilty trophy. So pretty impressive trophy. I took this. This is because this is their motto: 1 horse, 1 rider, 100 miles in 1 day. And to complete is to win. I thought that was fantastic. I just that sums it up. You just need to complete, and you've won. Now this is Tom Quilty 2025. That's some of the organisers that I helped them out taking some photos. And what I took somewhere here. Oh, there we go. Now there is the winner of the Tom Quilty. So this is Sunday morning. Sunday morning they have the presentations, and this was part of the presentations. That's the winner, and that's second place. So they get sashes and rugs and all sorts of things. If I do now, somewhere here, this is all of the winners of all of the different categories all lined up. Here we go. There's the winner. There's number 2, and we go all the way through to 10. So anyway, that was the Sunday morning. So it gives you just a little bit of an idea, and I'll get this back up. Sounds similar to Mawson in South Australia at the car rallies. Well and truly. And Colin, we used to do the Targa radios as well, and there's a couple of amateurs who still do Targa radios during Targa, and they travel around the place, put repeaters up and all sorts of things. So very similar, but the analogy I use with Equine Endurance, Colin, is the horses are going slow enough that you can actually have a conversation with the riders instead of watching the cars go whoosh past you. So that's the radio setup. You can see it's the ability to take the head off the radio. Fantastic idea. Just 2 cables, and that can be put anywhere. So that's a real plus for a radio where you can remove the head. So I just thought I'd, and I think I've covered pretty much everything. So that's an Equine Endurance event. Now, how are we going for time? Okay, going really well. Now, I'll stop the winners going past. There were quite a few winners in that. All right. Now, let's see how much of this I can get in. I may actually have to. Okay, now, I just wanted to go through a couple of articles that was in last month's, and I know this month's is about to hit people's letterboxes. This is the WIA magazine, and there is a really important article in here, and it's highlighted on the front: 5 megahertz, the truth. Now, this is written by Dale Hughes, VK1DSH, who is our ITU chair for Working Group 5A in the ITU, and also the last couple of World Radio Conferences, he has also been part of the delegation, the Australian delegation. So he know what I'm trying to say is he knows exactly what he's talking about. So he writes a fantastic and very detailed article about 5 megahertz or 60 meters, what everyone's talking about. there is a lot, can I just say, there is a lot of misinformation out there, and what this article was trying to do, that Dale was trying to do in this article, was try and dispel some of that misinformation. So well and truly worth a read, and the article highlights the amount of work that the WIA has actually been doing in relation to trying to get access to the 5 megahertz band. There was a 2016 submission, quite an extensive submission. There was an extensive 2018 submission, and then there was a 2020 submission, and that fed into in 2020 the ACMA making a decision that they were not going to support the amateurs application to allow access to 5 megs. Now, the other two users in 5 megs in Australia are Defence and also New South Wales Ambulance Service. Extensively use a HF network on the 5 meg band. So the fact that Defence and New South Wales Ambulance were the two key members that I suspect swayed the ACMA, the ACMA decided to side with them. Now, not all is lost. The WIA actually has a couple of allocations in 5 megs, fixed allocations. So if you were wanting to try using 5 megs for whatever reason, you can make an application to the WIA and see whether they will allow the usage for short periods of time. Not all lost, but general access to 5 megs at this point in time, so long as Defence still has an interest in 5 megs and the New South Wales Ambulance Service has an interest in 5 megs, we are probably not going to get access to 5 megs, which is unfortunate. There is one of the things in the article which is why it's worth the read is Dale goes through the highly structured process of making a submission to a World Radio Conference. And we have, as amateurs, through the WIA and through the International Amateur Radio Union, and then into the ITU, because the International Amateur Radio Union is the only body that the ITU recognises as the representatives of amateur radio. So there is a process you go through to build up from a country level into a region level and then into an international level and then into feeds into the deliberations that go on in a World Radio Conference. And World Radio Conferences are only held every 4 to 5 years. And so there is a whole process of meetings preparatory meetings that lead up to each country forming a view and forming their position on particular things that are put on the agenda, and they're put on the agenda very early, so countries know what they have to, what is going to come up for voting and debating and whatever else at World Radio Conferences. And World Radio Conferences go on for a good month. Every 4 to 5 years, so it's some pretty intense, and Dale goes into there was some pretty intense negotiation, both obviously in meeting rooms, but probably more likely in corridors and other places to try and get a position. And can I just say this whole process. The WIA has contributed to some pretty significant gains for the amateur service. Probably the main one that we remember is in 1979 at the WARC conference. So it wasn't WRC, it was WARC, the World Administrative Radio Conference in 1979. That was where we got the access to the WARC bands. So that's why it was called WARC bands, because it was the WARC 1979 that we actually got access to those bands. In 2012, we got access to a global allocation of 630 meters when they turned off all of the 500 kilohertz ship emergency frequency. In 2015, we got the global allocation of 60 meters, and then it was left up to all of the administrations to implement it. And in our case, unfortunately, the ACMA, our administration, didn't implement it. In 2019, we got the 50 megahertz in Region 1 was not available to amateurs. And at the 2019, we got Region 1 got access to the low end of 6 meters. And then in WARC 2023, which was the last one that was held, they actually, through lots of backroom dealing and lots of negotiation, prevented 23 centimeters from being removed from the band plan as an amateur band. And that was all about global navigation systems, GPS, GNSS type systems, and there was literally a prevention of it being removed, 23 centimeters being removed altogether as an amateur band. So some pretty significant wins there. So yeah, it's well worth. I know I'm banging on about it, but well worth a read. 5 megs, the truth. Now the other areas, there are some other interesting articles in here. The next article is AO7. So this is AMSAT Oscar 7. Is the oldest man-made space object still working. So I thought that was fantastic, and it goes into the history of it, which is really good. 1968, an auspicious April for amateurs in Australasia. And that was when the IARU Region 3 was formed, and there's a wonderful historic article around that. The Newcomer's Notebook, which is all about transmission lines, amateur transmission lines from Jules Perrin. Now, those people who went to our conference in November would have seen Phil, VK2ASD, who is WIA Education Committee, on the WIA Education Committee. And he did a presentation on EMR, so electromagnetic radiation, and using some tools to be able to model EMR in your backyard using the antenna you've got, and talks about exclusion zones and all sorts of stuff, and be able to assess the safety level of your operation at for your station. So there's a wonderful and I don't know, I doubt what we're, oh yeah, okay, that might work. There's a wonderful, this is right in the middle of the magazine, which is fantastic. This is the flowchart that you can work your way through to assess your station. So assess against class license requirements for EMR, also called EME, or electromagnetic emissions. So you can work your way through here. Now, one of the things in here is it refers to the RSGB EMR calculator. Now, what we have is the WIA has negotiated an agreement with the RSGB to enable us to use their EMR calculator. And I'll put a link to the EMR calculator in the video description, because one of the things about the calculator is a fantastic little piece of software that the RSGB has come up with. It enables you to put in some physical distances and bits and pieces. It also has a library of the commonly used amateur antennas. You obviously need to put in power levels and all sorts of stuff, and then the height of the antenna and where different things are. And it gives you a calculation of the exclusion zone. So the zone where you have to keep people out of. And the really good thing about it is it uses the same standard that we use in Australia. And so there is a great comparison between the European standard, which is what the RSGB has used, and also our Alpanza standard here in Australia. So I'll put a link in for the RSGB EMR calculator. We have also penciled in a forum night or a presentation night. I haven't quite worked out which one it'll be, on using the calculator. So we'll get some experience with using the calculator, and then we'll do a presentation on it and let people know what it's, how to use it, what the common things are that you've got to do, and how you actually then interpret the calculations that it's come up with. Now, hang on, let me just bring the chat up. Cool. Okay. Oh, we got Mark. I think that's FMAC. I'm not sure. Now, there's another relevant article in here. The Manly Warringah Club by Carmel Morris, VK2 November Oscar, on building the ADX transceiver. So there's a wonderful. Now we know about that in Reast, because we've just been through our own workshop down here of building our ADX receivers. The other thing that resonates with us is Kevin, VK4UH, has an article on testing the 5.7 gig transverters from SG Labs. So a number of us down here have got those, and we're using them. And so Kevin takes us through the testing of them. The Applied Mathematics book by Fred Swainston, which we featured last week, gets a bit of a feature, and in fact that's how I knew about it. And then there's the standard ones, the Below 25 by Alec Cherry, the Alara. And then there's a whole lot of contest pages. The Australia Day contest, the contest champion results for 2023, the Ross Hale contest, and now this is what I want to show you, because one of the things that appeared in here, now let me find, oh, I've lost it again. Don't you hate that? Where's it gone? I really do have to, there we go. So, in an article called Spectrum Horizons, there was a little 6-meter history on display here. Now, can I just take you to a Antarctic festival last year, and it got a bit of a go in AR magazine. So I thought I would show you the actual item, and I needed 2 people to actually put that up on the desk, just putting it out there. But anyway, that's AR magazine for. Now this is volume 93, number 2. 2025. Now, volume 93, number 3 is about to be put in your letterboxes. So there you go. Now, how are we going for time? Ooh, okay. Let me zoom ahead here. All right. This is my little history piece. This is my little history piece. All of us, I assume, use Rosin Cored Solder. And Rosin Cored Solder is one of those tools that everybody has in their shack. I use it all the time when I'm building something, or I'm putting a cable together, or whatever else. And I take it for granted that it is solder. And yes, I still use tin lead solder. I don't use lead-free solder. Can't stand the stuff. but I'll take the risks with that. But in the center of that resin, of that solder, there is a little hole all the way through the solder, which is filled with what we call flux. And I came across this little device. This We are getting a stream deck, so once we get the stream deck, I'll be able to very, very quickly change to bits and pieces. But now I was looking in a box, and in the bottom of this box there was Gardner Rosin Cored Radio Solder. The flux is in the solder, and I suddenly realised, we take resin cored solder for granted, when in fact it's only about the late 1930s, 1940s that resin cored solder became commonplace. And before that, we actually used flux and solder, and they were separate. Now this is a bit modern because it's got 150 grams on here, so this is a replica tin, but it's still got flux in it, and I still use it for large solder jobs, and where you're sweating things onto large bits of copper, where you need lots of heat and you need lots of flux. So I suddenly realised, okay, we're taking this wonderful resin cored solder for granted. There's no solder in there, I'll just say. All been used, but I started looking into a little bit of okay, when did rosin cored solder become commonplace? And I came across the patent, the 1929 patent for rosin cored solder, which is well and truly expired by now. But so 1929 was when it was patented, and common use, in my reading, common use was around about the 1930s and into, and can I just say, World War II seems to appear as the impetus here for commonplace rosin cored solder, and so the building of equipment and all of that sort of thing sped up. I suspect the use and the distribution of it. And Paul, you're spot on. This is still used for plumbing solder, where they are soldering. They don't tend to solder gutters these days. They're riveted together and they're celastic and all sorts of stuff. But in the old sense, they were galvanized gutters. And you could then put the flux on, and then you had a big stick of solder, and you had a big a plumber's soldering iron that had a head on it that was quite large. So, and that's one of the reasons I kept this. I still use where I need a lot of flux. And now, the other question is, why do we need flux? What makes flux so special, and why do we need it in the center of our solder, or we need it in a tin? All flux does is, and there are two types of flux. You've got an acidic flux, and I've got a bottle of acidic flux. Fairly scary stuff. I think it's hydrochloric acid. But it's either acidic or it's some sort of chemical reaction. Some sort of other chemical reaction. So acidic they call active flux. And then rosin, which is used to be a natural base, it's now a synthetically created base, but they call rosin a passive flux. But flux, all that does is prepare the surface and take the oxidization off the surface, so that you can more easily solder to it. And that's why if you've got solder with no rosin in it, you will have real trouble getting the solder to take to any surface that has been exposed to the air for any length of time. And so what the flux does is prepare that surface, get rid of the oxidization, and present a cleaner surface that the solder can then bond to. So that's the reason for flux. And it was only around the sort of the start of World War II, 1939, 1938, where rosin cored solder was commonly used. And I couldn't find a date on here, but the whole thing, the thing about Gardner's radio solder is the flux is in the solder. This is around which was obviously revolutionary at the time. But anyway, common thing that we take for granted, and it hasn't been around for forever. So all right, we'll finish up now. So just a reminder of future events. 31st of May, we've got a standard advanced and regulations assessment day. We've got reminders. So June the 2nd, so next Wednesday night there is a class license Q&A, which will be hosted by myself and Peter, VK3MV. It is a little bit of a presentation on the class license, hopefully dispel some of the myths that seem to have been brewing, and then we'll take a question and answer about any aspect of the class license or the framework that's around it. A bit of a reminder, June the 9th to June the 16th, which includes a Wednesday night in there and a Wednesday, the club rooms will actually be closed. We won't have an experimenters night because we are having the ceilings replaced in here. So they are going to a standard 600 by 600 ceiling arrangement. Then on June the 18th, we've got a forum night, which is Essential Shack test equipment. And a bit of a plug, Saturday and Sunday, June 21 and 22 is the Winter VHF and Above Field Day. And I'll just give you a little bit of a taster. On Wednesday, July the 2nd, we have a really special presentation night. So I'll leave it at that. So that's your blooming lot. Oh, no, hang on. Flux. Or at least for copper connections. Yeah. Copper and galvanized connections. Flux as well. You probably need a bit of a wire brush on the galvanized because it does tend to oxidize really easily. Always add extra flux if you are soldering a wire onto a lug so that the solder runs along the whole lug. Spot on, Stephen. Well and truly. And it seems a bit sort of counterintuitive, but when you've got solder wick, now all solder wick is copper braid that is impregnated with flux. And the problem with solder wick is it is to get things to start to flow. And you need a certain amount of heat. And one of the ways to get it to start to flow is to put just a dab of solder where the soldering iron is, and suddenly everything starts to flow. And it seems a bit counterintuitive to put solder on solder wick, but it gets everything moving and drawing the solder off the board and out of the holes into the flux that's in the solder braid. So there you go. I absolutely love it. So that's your blooming lot for this week, and I hope you've learnt something out of all of that. And next week, class license Q&A. So hope to see you at the class license Q&A. And yeah, 73, and we'll catch you next week on the stream, and we will be streaming the class license as well. So get your class license questions together and drop them in the chat, and we will attempt to answer them. So 73, this has been VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night. And we'll bid you, if I can find the cursor again. I really do need to work out how to do this. There we go. So, 73. Catch you around.